What is the functional group for carboxylic acid?
COOH.
COOH. Yes, correct. It is COOH. And by the way, I'm having a mouth ulcer today, so my pronunciation may not be that accurate. So do not laugh if I fumble on some words. Okay, it is very possible that I might fumble on some words. Something else can come out of my mouth if I'm saying something else. So do not laugh in that situation if it happens. Okay, I may fumble. I may fumble. I'm already giving you warning. Is it clear for error? Okay, sure. Let us start with carboxylic acid. Now in the carboxylic acid, as I told you, in every chapter in organic chemistry, there is first preparation, properties, reaction. Preparation, properties, reaction. Preparation, reaction. That is the only two things you have, preparations and reactions. Okay. So first, we are going to start with the preparation of carboxylic acid. Let us start with the, give the heading preparation of carboxylic acid. Give the heading preparation of carboxylic acids. Preparation of carboxylic acids. Preparation of carboxylic acid. Okay, now we want to prepare carboxylic acid. So first we are going to prepare it from alkyl benzene. Alkyl benzene, like give me an example. Like for example this. What is this? What is the name of this? Prashanti? Prashitaran? Yeah, what is the name of this? Toluene. Yes, correct. It is toluene. Just a minute, just a minute. Yes, it is toluene. Yes, it is toluene. Yeah. So alkyl benzene, that is your toluene. If I oxidize it, yes. What is oxidation? Sashidharan, Prashanti, Ragul, Gopinath. What do we mean by oxidation? For organic chemistry, do not tell me in terms of electrons. Tell me for organic chemistry. What do we mean by oxidation?
So addition of oxygen or removal of hydrogen. Oxygen.
Addition of oxygen or removal of hydrogen. Okay, that is oxidation. So always remember if you are oxidizing an alcohol, okay, remember this. If you have a hydrocarbon, okay, if you oxidize it with the mild oxidizing agent, it will convert into alcohol. Okay, it will convert into alcohol. If you further oxidize with mild oxidizing agent, it will convert to aldehyde or ketone. Correct, Prashanti? And if you further oxidize it, it will convert it to carboxylic acid. But if you use a strong oxidizing agent, it can directly convert alcohol to acid also, or hydrocarbon to acid. Both of them is a possibility. Okay, if you use a strong oxidizing agent, and that is what we are going to use now. Okay, that is what we are going to use now. Like for example, over here, if I use alkaline KMNO4, okay, so generally alkaline KMNO4, it can be also given as KMNO4 KOH, one and the same. KOH means alkaline medium. KOH means alkaline medium, that is basic. Okay. Now tell me, Sashidhar and Prashanti, you must be watching movies. Who is your favorite villain? Can be from your regional movie also. That's fine. Who is your favorite villain?
Sir, in Tamil, Mansoor Ali Khan is one of the favorite ones.
Okay. There is a, yesterday when I asked in one of the batch, no, one common villain name came out. That was Rolex. Yeah. Rolex. Yeah. See, even Prashanti is saying, I have to watch this movie. Which movie is this? Yeah. Yes, Sashidharan. Which movie is this? Which has a Rolex as a
It is
villain?
Vikram, sir.
It is Vikram. Vikram.
Kamal Hassan movie. So.
Yes. Vikram.
And there is also like Vikram is only for Kamal Hassan mainly. Rolex was part of it, and another film coming only for Rolex, like that Surya character alone is coming.
And definitely because everyone in the batch, everyone said Rolex. Everyone from the batch told me about Rolex, and I was like, I have not seen it. Now I have to see this. Okay. So alkaline caminophore is like a villain. Okay, a very strong villain, a very strong oxidizing agent. Yeah, just like my Thanos. Thanos is my favorite of Marvel. Yeah, one snap, everything is gone. Yeah, one snap, everything is gone. Similarly, alkaline caminophore is like that. One snap, everything got oxidized. So your alkaline CH3, your alkaline caminophore is so strong that it will convert your CH3 direct to carboxylic acid, direct into carboxylic acid. Now, now, no matter, look over here. Suppose even if I have a ethyl benzene or a propyl benzene, suppose I have a ethyl benzene. Suppose I have a ethyl benzene. Now, no matter how many, even if I have 100 carbon chain, even if I have a 100 carbon chain, okay, even if I have a 100 carbon chain, the alkaline caminophore, your Rolex or your Thanos, one snap, everything is gone. So it will give you only one CO4. Remaining everything is gone. No matter how many carbon atoms are there, if you use alkaline caminophore, it is so strong that it will always give you, what is the name of this? Yeah, what is the name of this? Prashanti, Sasidharan, Ragul, what is the name of this? The
Benzoic
product, the
acid.
name of the product. Yes,
Benzoic acid.
yes, it is benzoic acid. It is benzoic acid. Come on, write it down, Prashanti, Sasidharan, write it down and tell me done. Ragul, Gopinath, come on, write it down and tell me done. Come on, write it down and tell me done. Prashanti, write it down and tell me done. Put the reaction. Write it down and tell me done. Done. Okay, fine. Sure. Let us go ahead. I hope Sasidharan, you are writing it down. Where is your pen? Why your pen is so far?
Sir, the disc is big, so
Mm-hmm.
I have like notebook and pen. I kept it together.
Okay. Now next is from nitriles and amides. Now nitrile, what is a nitrile? Prashanti, what is a nitrile? What do we mean by nitrile? Yeah? What do we mean by nitrile? What do we mean by nitrile? Yeah? Prashanti, Sasidharan? What do we mean by nitrile? Okay, very good, Prashanti. Yes, Sasidharan, what do we mean by nitrile? Nitrile is nothing but C triple bond N. Your Cn is your nitrile. Cn is your nitrile. Okay, cyano or nitrile. So whenever you have a nitrile, look over here. Suppose I have a nitrile. What are we doing? We are doing the preparation of what, Sasidaran? We are preparing carboxylic acid. We are preparing carboxylic acid. Okay. So if I have a nitrile, okay. So this nitrile, okay, I have a nitrile. This nitrile, if I hydrolyze it, always remember this. If I hydrolyze nitrile, look over here, it will hydrolyze like this. CH, C triple bond N. Okay, it hydrolyzes in a funny way. This is H2O. If I hydrolyze it, okay, OH2. OH2. So what I'll get? CH3, C double bond O, NH2. What is this? Sasidaran, what is this? Prashanti, CH3, C double bond O, NH2. CH3, C double bond O, NH2. What is this? Amine? No. RNH2 is amine, Sasidaran. RNH2 is amine. Yes, Prashanti, CONH2. CONH2. Prashanti, it is amine. Okay, it is amine. And if I further hydrolyze this, look over here. It further undergoes hydrolysis, OH. What I get? CH3, C double bond O, OH plus NH plus NH. Are you getting it? So what did we get? This is your carboxylic acid. What is the IUPAC of this? The product. What is the IUPAC of product? Yeah. What is the IUPAC of product? Sasidaran, Prashanti. What is the IUPAC of product? Ethanoic acid. Perfect. So I have a 2 carbon. It is an acid. So 1, 2, 2 carbon, oic acid. So it is ethane oic acid. It is ethane oic acid. Come on, write down the reaction. Sasidaran, write it down. Prashanti, write it down. Come on, organic, you have to write it down. No option. Come on, write it down. No option. Just a minute, Sasidaran, Prashanti, just give me a minute. Yeah, chalo. Is it done? Sasidaran, Prashanti, is it done? Okay, fine. Chalo. Let us go ahead. Yeah. Now, After this, okay, this was your ethanoic acid. Now, what if I'll give you one question, Prashanti Sasidaran, I'll give you one question. Suppose I have CH3, you have to tell me the IUPAC here. CH2, suppose I have a CH3, CH2, CN, H2O, H2O, twice hydrolysis. Come on, you have to tell me the IUPAC of the product. You have to tell me the IUPAC of the product. Come on, do the hydrolysis. You have a nitrile. Just now we have learned that if you have nitrile, you hydrolyze what you get. If you further hydrolyze, what you get. You have to tell me the IUPAC of the product. Prashanti Sasidaran, you have to tell me the IUPAC of the product. Yes, what will be the IUPAC, Sasidaran, Prashanti?
Sir,
Yes, Sasidaran.
it's 3-methyl butanoic acid.
3-methyl.
Butanoic acid.
Why not 2-methyl?
Sir, COOH is at the last, so we should take from the functional group.
Is it the rule that you have to start from the functional group, or no? You have given the correct answer. Okay, you have given the correct answer. But what is the actual reason? Like over here we are starting 1, 2, 3, 4. Why not 1, 2, 3, 4? Because we are not, even though you are saying butane oic acid, it is butane 1 oic acid. Are you getting it? If I start from this will be 2, 4. Over here, if I start from this 1, 3. So 1 plus 3 is 4. 2 plus 4 is 6. So 4 is lesser. Lowest locant group.
Local
Lowest locant group. Getting it?
yes, sir.
Yeah. So this is your butanoic acid. I hope it is clear. Yeah. Now let's go to next. That is after your preparations from nitriles and amides. Now this is it can be done in the acidic medium as well as basic medium. Okay, both of it is fine. You are just doing the hydrolysis. Okay. Now next is from Grignard reagent. What is a Grignard reagent? See, I'm not able to pronounce it. What is Grignard reagent, Sasidaran?
RMGX, sir.
Hmm?
RMGX.
RMG. And what is the use of it? Like, what is the use of Grignard reagent? Yeah?
Sir, in oxidation.
No. Think logically. No, think logically. Think logically.
Sir, addition
What?
of an alkyl group.
Why? And how? Just because Google is saying.
No, sir.
Then?
Sir, no, sir. Like when we reacted with Grignard reagent, OMGX will be there, and also alkyl group also. Like
Why?
RMGX gets dissociated as R minus and MgX plus.
That is important. R
And
minus
MgX
Mg.
plus goes to O minus and
Magnesium. What is the oxidation state of magnesium in periodic table?
so
What
plus
does charge? And tell me any magnesium compound.
magnesium hydroxide,
Tell me the formula of it.
MgOH.
See, no, it is MgOH twice. Okay, MgOH twice. MgCl twice. Why? Because
Plus 2.
Mg is plus 2. Yeah, Mg is plus 2. So this is plus, this is minus. Getting it? So to have plus 2, you require minus 2 minus 2s also. Are you getting it? So that's why this is R becomes minus. It is giving you a nucleophile. It is giving you a nucleophile. Okay. And do you know about dry ice? Dry ice. Sasidaran, have you seen it? Dry ice. Dry ice.
Sir, in some videos I have seen.
What? What is it?
It like vapors and all will be coming soon.
What do you know the special property of dry ice?
So I think it is condensed carbon dioxide, sir.
Condensed carbon dioxide. So the special property is sublimation. What is sublimation?
Conversion of solid directly into vapors.
Yes, solid directly into vapor. So your dry ice. Do you know the formula? It is, as you said, condensed carbon dioxide. It is carbon dioxide itself. Getting it? So if I have a carbon dioxide, that is your dry ice, and RMgX and RMgX. So what will happen? Where will this attack? You have R minus. It will attack at the carbon. This opens up. So what I'll get, Sasidaran? I'll get something like this: R C double bond O minus. Are you getting it? O minus. And obviously MgX you have, so this becomes MgX. If I hydrolyze it further, so RCOOH plus MgOH. MgOH. Come on, write it down. Write it down. I'll give you one question to do on this. Come on, write it down properly and understand this. Prashanti, understand this. This is your Grignard reagent. This is your dry ice. Dry ice. This is your Grignard reagent. And what you have prepared? You have prepared a carboxylic acid. 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 Finish it? Done. Okay. Chalo, Prashanti, is it done? Okay. I'll give you one question on this. Suppose I have, okay, CH3, C, CH3, CH3, Cl, okay, look over here, Sashidharan, first Mg, second, and this is, such questions come in the exam, CO2, third, hydrolysis, come on, try this. What will happen in the first step, Sashidharan? What is that?
Sir, addition of Mg.
Where will you add it?
Sir, in like the center carbon.
See that whenever you have RCl, always remember if you react with Mg, It is insertion reaction, RMgCl. RMgCl. Getting it? Getting it, Sasidharan?
Yes, sir.
Come on, do it. Do it now. Enough of help. Do it. Tell me the IUPAC of the final product. Prashanti, tell me the IUPAC of the final product. Tell me the IUPAC of the final product. Yes, Prashanti, try. Tell me the IUPAC of the final product.
Sir, it's 2,2 dimethyl propanoic acid.
Yes, correct. So what will happen over here? We will have CH3, C, CH3, CH3, NgCl. Correct? This negative attacks on the CO2. If it attacks on the CO2, that is C double bond O double bond O. This gets added, MgCl gets added to oxygen. So CH3, C, CH3, CH3, C double bond O, O, MgCl. That is your after you do the second reaction. When you do the third reaction, MgCl goes away, Sasidharan, and what do you get? You get a carboxylic acid. You get a carboxylic acid. So over here I will have a so 1, 2, 3. So 2,2-dimethyl propanoic acid. 2,2-dimethyl. Write it down, Prashanti. 2,2-dimethyl propanoic acid. I hope it is clear, Sasidharan. Okay. Now tell me this, Sasidharan. This is also common question. Same thing. Same thing. Yes, we are doing it. Prashanti, first you write it down. I am taking one more example of this. Same thing. Prashanti, we are going to do same thing with this reagent. Yes, what did you get, Sasidharan? Prashanti?
Benzoic acid, sir.
Yes, Sasidharan?
Benzoic acid.
Yes, it is benzoic acid. It is benzoic acid. Now look over here, Prashanti, how to do this. So I have Prashanti a benzene and a Cl. Okay, I am reacting it first with Mg. So whenever you have Mg, Prashanti, always remember, as I told you, Mg gets inserted in the RCl. Correct? Similarly, Sasidharan, what will happen? Mg will get inserted between this. So after doing the first reaction, Prashanti, what are we getting? We are getting MgCl. Now due to Mg, it has become plus. Prashanti, this has become negative. Now in the second, we react it with CO2. In the second, we react it with CO2. So when we react it with CO2, what will happen? This negative attacks on the carbon, this opens up. Negative attacks on the carbon, this opens up. Correct? So what we will get over here, benzene, C double bond O, which is already there, and the O minus, and the O minus. Are you getting it, Prashanti? And this MgCl positive will come over here. Yeah. And if I hydrolyze this, Prashanti, if I hydrolyze this, hydrolysis means what? H and OH. Correct? So it over here minus is there, so H plus, over here OH minus. So what did I get, Prashanti? I have got benzoic acid. C double bond O, OH plus MgClOH. Is it clear, Prashanti? Sasidharan, is it clear? Go and write it down, Prashanti, write it down. We'll go to next. Very easy. Should not lose marks in this. Very easy. Write it down, Prashanti. Done? Okay. Now give the next heading. What are we doing, Sasidharan? Our topic is we are preparing carboxylic acid. We are preparing carboxylic acid. So give the next heading from acylchlorides. From acylchlorides on anhydrides. What are acyl? What is acyl group, Sasidharan? What is the acyl group? Yeah.
RCO.
It is RCO. Okay, it is RCO. So suppose I have a RCO group, that is, suppose I have CH3 CO group and a chloride, that means I have a Cl over here. Okay, I have a acyl chloride. So same like the last reaction, amides, nitriles, everywhere we have done. If I hydrolyze it, Sasidharan, yeah, if I hydrolyze it, H2O, what will happen? This is plus, this is minus, so OH over here, H over here. So what did I get, Sasidharan? CH3, C double bond O, OH plus HCl. Now this is what happens in the acidic medium. Is it clear? Very easy, very easy. Just you have to hydrolyze it. But if you have a basic medium, then there's a slight problem. Why? Because if you do hydrolysis in the basic medium, Sasidharan, this is CH3. Again, if I do the same thing, yes, in a basic medium, okay, I'll get the product, but your CH3COOH is an acid. OH minus is a base. So what will happen? Acid will behave as acid, will give away the H plus. Base will behave as a base, take away the H plus. So first you will get an intermediate like this. O minus. Are you getting it, Sasidharan? If you use a base, you will get an intermediate. You get an intermediate. Then you further acidify it. Further you have to acidify it so that you get an acid. Get an acid. I hope I am clear, Sasidharan. Yeah, come on, write this down. This is your acyl chloride. Come on, write it down, Prashanti. I hope I am clear, Prashanti. Come on, write it down. See, organic chemistry you have to write and practice. There is no other option. You have to write. Done, Sasidharan? Okay. Then after acyl chloride, we have anhydride. Anhydride. What is anhydride? What is anhydride? Yeah, Prashanti, Sasidaran, I call it as bullet. Like, it does not have anything related to bullet, but I call it bullet because it looks like bullet. Look over here. This is an anhydride. You also remember it like this. It will be easy. CH3CO, O, CO, CH3. This is your anhydride. This is your anhydride. This is your anhydride. So again the same thing. So again the same thing. So in the book they might give you like this. They will give you like this. CH3CO twice O. This is your acetic anhydride. This is your acetic anhydride. Acetic anhydride. Okay, acetic anhydride. So if I hydrolyze this, Sasidaran, again H2O. So what will happen? This is partial positive, partial negative. It will break. Positive will get the negative OH minus. This will get H plus. So what I am going to get? I am going to get CH3 COOH. So two molecules of acetic acid. So again, what we have prepared from the anhydride, write it down. This is an anhydride. From anhydride, you have prepared carboxylic acid. You have prepared a carboxylic acid.
Sir,
Yes, Sasidaran?
sir, in every case, like for acylchloride also, we are like if you are taking like one molecule, like uh, one acylchloride means you will get two like one carboxylic acid, sir. But in acetic anhydride alone, if you are taking one anhydride, we are getting two alcohols.
Yeah, because
So
the CH3CO part is repeated twice, no? That's why.
no, sir. Like, is this used for commercial purpose, sir? This one, like because for more yield of alcohol.
No, no, not like that. It is not that even acetic anhydride is easily available. Not like that. No, generally we do not use this.
Okay, sir.
Is it done? So let us go ahead. Now we have seen the preparation of acid using your acyl chloride and acetic anhydride. Now let us go to the next. Please ignore my punctuations today. Okay. Now next is what we are going to use ester. Okay. Next is what we are going to use ester. Ester. What is the functional group of ester? Yes. What is the functional group of ester, Sasidaran? Prashanti? Yes. Sasidaran?
RCOOR.
Yes. It is RCOOR. That is your ester. That is your ester. Okay. So I have an ester. Okay. I have an ester. So if I take ester and I do the hydrolysis. Okay. If I take the ester, see all of these reactions are hydrolysis only. If you notice, Sasidaran, all of the reactions are hydrolysis only. Suppose if I have an ester, CH3, give the heading from ester. From ester. So suppose I have an ester CH3 C double bond O C2H5. So again, you only tell me by your logic what will be the two products. Sasidaran, Prashanti, tell me by your logic what will be the two products.
Sir, one will be carboxylic acid
And
and another will be alcohol, sir.
yes, alcohol. So over here we will have a carboxylic acid and then alcohol and then alcohol. Simple. Yeah, simple. But Sasidaran, what is the IUPAC name of this? What is the IUPAC name of it? Prashanti?
Sir,
Yes, sir.
Ethyl methyl.
Methyl. No.
No, no.
Ester, what suffix do we use, Sasidharan? Do you know? Okay. For ester, we use OH. We use OH. Now look over here, Sasidharan. Like whatever oxygen, no matter even if you have 100 carbon, after oxygen, whatever you have, we consider it as a branch. Okay. And your carbon side, we consider it as a parent chain, even if we have a one carbon. Even if we have a one carbon. Okay. So parent chain, how many carbon are there? Sasidharan, 1, 2. 2 carbon means? 2 carbon means ethane, correct? But we have a ester, so it is ethane OH. It is ethane OH. And branch is again 2 carbon ethyl, and the oxygen, it becomes ethoxy. So ethoxy ethanoate. Ethoxy ethanoate. Are you getting it, Sashidharan?
Yes, sir.
Suppose I have Prashanti. Suppose I have H, C double bond O, CH2, CH2, CH2. Come on, tell me. Tell me the name of this.
Sir, it's propoxymethanoate.
Yes, propoxymethyl. Come on, write it down. So the point is, Sasidharan, no matter how many carbon are there after oxygen, that is considered it as a branch. That is considered as a branch. This is your parent chain. So one carbon is methane. So Prashanti, it becomes methanoate. Correct, Prashanti? It will be propoxy methanoate. Propoxy methane. Come on, write it down, Sasidharan. Prashanti, write it down. Done? Okay. So let's take a break. After the break, we'll start it. The last method from the alcohol. We are going to prepare the most important method is what I'm going to take after the break because you will be fresh. That is from alcohol. Okay. So let's take a break. It is 8. We'll start sharp at 8:10. And Sasidharan, you have to come on time. It is your record. Every break you come 5 minutes late. Getting it? What? Are we back, everyone? Yes, Sasidaran, are we back? Sasidaran? Sasidaran, are we back? Are we back, Sasidaran? What did you do, Sasidaran? Did you go to some religious place or what in 10 minutes? What?
Sir, my mom just passed like near me, so she.
What? You were studying, suddenly mom comes.
Yes, sir.
I should not make joke on this, but okay.
Like she said at the starting of the class itself to have a face mask and then sit. Then, she said after applying this, she said like when I'm telling itself, if you have kept, you could have kept it like small, but when I am keeping, I will keep it like this.
Okay, fine. Chalo. No issues. Just a minute. Just a minute. Okay. Chalo, let us continue. Now, where were we? Okay, we have completed from ester. Now, yeah, the next important, give the heading. We are going to prepare carboxylic acid now from alcohols. We are going to prepare it from alcohols. Give the heading from alcohols. From alcohols. From alcohol. Now simple it is. From alcohol, how do we prepare it? Simple. Yeah.
Sir, by oxidation.
From
Oxidation.
Yes, oxidation. That is using a very strong oxidizing agent. Yeah. If I use a very strong oxidizing agent, suppose yeah, KMNO4. Yeah, we can use that. Just now we did KMNO4 KOH. Yeah, we can use that. But you know there is one intermediate, and that can come in exam. Like suppose I have suppose I have CH3 CH2OH. Okay, CH3 CH2OH. Okay, and if I use KMNO4 KOH, okay, in the alkaline medium. Now just now I told you, Sasidaran, yes, it will give you acid, but since it is a basic medium, what we will get? First thing that we will get is what you do not like to do, that is cook. Yeah, COOK. That is the KMNO4 is there, no? So KOH is there, correct? It is a base, so OH minus will take away the H plus of acid and will put K plus over there. Are you getting it? And when you acidify it, you will get the acid back. You will get the acid back.
So can we also use acidified K2Cr2O7? So directly we can.
We can get acid in that case. But there are different ways with which we can create acid, which we can prepare acid. Okay, so you can use acidic K2Cr2O7 also, no issue. Yeah, but if you use any basic medium, okay, if you use any basic medium, you will have cook in between. You will have cook in between. Getting it? Okay, so simply if I use any oxidizing agent, we have seen that alcohol gets converted to aldehyde, aldehyde gets converted to your acid. But if I use a strong oxidizing agent, alcohol will directly get converted into what? It will be directly get converted into your directly get converted into what, Sasidaran? Into acid. into acid. Clear till over here? Yes, Sasitharan, Prashanti, clear? From alcohol, how do we prepare it? From alcohol, we simply oxidize it. Yeah, simply oxidize it and you'll get it. Now, for acidic medium, even K2Cr2O7 in acidic medium is quite mild, not as strong. Sasitharan, for acidic medium, you can use a Jones reagent. Okay, you can use a Jones reagent. That is your CrO3 H2SO4. This is a better one. Okay, so again, if I have alcohol, it will directly give me acid. Directly to the acid. Only be careful, Sasitharan, that number of carbon should be same. Number of carbon. By mistakenly sometimes what we do, OH, we directly convert it to COH. Okay, and that will be there in one of the options because that is a silly mistake that we do. Clear?
Yes.
Okay, so from alcohols,
So
they will.
in our school they gave like alkaline KMnO4 and acidic K2Cr2O7 as strong and
No, acidic. Wait, I'll give you the list. I'll give you the list. I have the list from the reference book. Yesterday only I took out the list. Just a minute.
our teacher gave like for both oxidizing agents and reducing agents, strong oxidants and reductants, and for mild and also weak.
What acid did she give? H2SO4, did she give concentrated acid or dilute acid?
Now,
Concentrated
like, no
H2SO4.
mention of that like concentration, sir. Like acidified, like H2SO, K2Cr2O7, H2SO4.
Because if you use, see, there are various ways. Okay, like if I use Cr, like K2Cr2O7 and H2SO4, and if that H2SO4 is dilute, no, it will act as a mild oxidizing agent. If I use H2SO4 with dilute, okay, it will act as a mild oxidizing agent. Okay, even your Jones reagent, if I use acetone over here, no, if I use extra acetone over here, it will also act as a mild oxidizing agent. It will also act as a mild oxidizing. Wait, I have a list of mild oxidizing agents. But if you use dilute, see, if they do not mention dilute, then use it as a strong. But if they mention dilute, that means you have a mild oxidizing agent. See, this is the list. Okay, even Jones reagent, Prashanti, if you notice, even the Jones reagent, yeah, is coming under mild oxidizing agent. Why? Because there is acetone. If I use acetone, it will be mild. Okay, if I do not use acetone, it will be strong. Even your PCC, this is also common. Does not touch double bond. PCC is also very common. Yeah. Even copper, your chlorine. Yeah. Take a screenshot of this. Take a screenshot of this. These are your mild oxidizing agents. These are your mild oxidizing agents. Done? Can we go ahead? Yeah. Now let us talk about the chemical reaction. Before that, let us talk about acidity. Let us talk about acidity. Okay. Since we are talking about carboxylic acid, we have to talk about acidity. It is like a property of acids. Yeah. What is an acid? How do we define an acid? Yeah. Sasitharan, how do we define an acid? What is an acid? Prashanti, what is an acid? Very good. Donates the proton. Donates the proton. What is a strong acid? What is a strong acid? How do we see the strength of an acid?
So, if it donates more proton?
More proton. What do we mean by more proton? Like, why will someone donate more proton? Why will someone donate less proton?
So, no, our ability to lose a proton easily.
That is an appropriate definition. Like, it can give away proton easily. The more it can give away proton easily, that means it is a strong acid. Are you getting it? Like, let us take the example of alcohol. Okay, like in the exam, Prashanti, Shashidharan, if the question comes, let us say I have an alcohol, let us say I have a primary alcohol CH3 CH2OH. I have a secondary alcohol CH3 CH CH3OH, and I have a tertiary alcohol, let us say CH3 CH3 CH3OH. Which is the strongest acid in this? If I compare acidity of A, B, C, which will be the strongest? Do you know, Sasidaran, Prashanti? How to check acidity of this?
Sir, C is more acidic, sir.
Why?
Sir, if it loses one like hydrogen from there,
Uh-huh.
like the negative
Car
charge.
as soon as we see tertiary, we think of carbocation, isn't it? Huh? No, look over here. A is the strongest. See how you have to check. Okay, like what is an acid, Sasidaran? Which donates the H plus. Okay, which donates the H plus. So let us donate the H plus from everything. So if I donate the H plus, Prashanti, minus, minus, minus. Why? I have donated H plus. That means what? Suppose I have carbon, oxygen, hydrogen bond. Okay, alcohol bond. H plus means what? It is leaving behind its electron. It is going as H plus. It is leaving behind its electron. It is H plus. Correct? So over here, think about this, Sasidaran. When someone, like when some bond breaks, why does that bond break? Like if I break the H bond and if I get a stable species, if I break the H bond, like after breaking a bond, I am getting a stable species. That means that bond will break easily. Are you getting it? After breaking the bond, if I am getting a stable species, that means that bond will break easily. Okay. So you have to check after donating H plus, who is the most stable. The most stable species will be a strong acid. Is it clear, Sasidaran? Stability of anion, stability of anion after donation of proton will tell you about the acidity. It is directly proportional to acidity. Now, how do we check stability, Sasidaran, over here? When is your compound stable? Prashanti, when is your compound stable? When it does not have any charge, when it has a minimum charge. We do not want charge on our compound. Okay, so over here, Sasidaran, you have an oxygen negative. Okay, now over here, one carbon is giving inductive effect. Inductive effect means what? It is giving away electron density towards oxygen. Over here, only one carbon. Over here, Sasidaran, it is two carbon which is giving away electron density towards oxygen. Over here, three carbon are there which are giving electron density towards oxygen. Now, since it is giving electron density towards oxygen, the electron stability decreases. It is becoming more negative. Are you getting it, Sasidaran, Prashanti? It is becoming more negative. And hence, Sasidaran, your A is the strong, then B, then C. Is it clear? Sasidaran, is it clear? Prashanti, any doubts, Sasidaran, in this? Is it clear? Prashanti, is it clear? Okay. Is it clear, Sasidaran? No doubt, no? Okay, now let us talk about, Sasidaran, let us talk about our carboxylic acid. Now, suppose I have CH2COOH. Now, you both tell me, okay, and I have OCH3 and I have NO2. A or B, suppose this is A, this is B. Who will be stronger acid? Which one will be stronger acid? Which one will be the stronger acid? Prashanti, Sasidaran, which one will be the stronger acid?
Sir, I think B, sir.
Hmm?
B, B.
Why?
Sir,
Yes,
NO
exactly.
decreases the electron density.
Over here, this is your electron donating group, Prashanti, and this is your electron withdrawing group. This is your electron withdrawing group. So what is happening, Sasidaran? If I donate the H, what charge will come on oxygen? Oxygen will get a negative charge over here. Withdrawing group is taking away the density from the oxygen. Are you getting it? Minimizing the negative charge. Donating group is oxygen. Are you getting it, Prashanti? Hence, if you look at the acidity, A is smaller than B. Is it clear, Sasidaran? Is it clear? Okay. So I'm giving you the order. I'm giving you the order, Sasidaran. Please write it down and you have to remember this. Okay, you have to remember this. So strongest electron withdrawing group. I'm giving the order of electron withdrawing group. Okay, I'm giving the order of electron withdrawing group. Okay, so strongest is CF3. Okay, then you have a nitro group, that is NO2. Okay, after NO2 you have a CN. Okay, after that fluorine, obviously. Then your halogens, chlorine, bromine, iodine, chlorine, bromine, iodine, and last but not the least, your phenyl ring. Phenyl ring. Come on, write it down. Write it down. Okay, so suppose I have come on, tell me from strongest to weakest. Suppose this is, and number it A, B, C, D. Which is the strongest? Obviously, strongest acid.
Sir, C is more.
Yes, correct. C is the strongest. Then you have chlorine A. Then you have B, iodine, and in the last, the normal acid. Okay. Did you write down the order, Sasidaran? Order is done, Prashanti. Order is done. Doing. Okay. I'm giving you one more order from your textbook actually. Okay, from your textbook, please write it down. Write it down right now. Okay, write it down right now. Okay, just a minute. Write it down right now. Okay, like it is logical. It is logical, Sasidaran. You have CF3, then Cl3, Cl2, only NO2, and C like that. Okay, come on, write down this. This is the order of acidity. Come on, write it down, Sasidaran. There is a book and pen. Come on, write it down. Write it down, Prashanti. Important is important. And just give me a minute, write it down just a minute. And tell me done after you write it down. Done, Sasidharan? Writing. Write it, write it. Done. Okay. Sure. Now we are completed with the preparation part. Let us go to the reactions. Reactions of carboxylic acids. Reactions of carboxylic acids. Reaction of carboxylic acids. Okay. Now first, which is a very common reaction, Sasidharan, that is you form an anhydride. What is anhydride? Just now we discussed. Yeah. Formation of anhydride. Formation of anhydride. Anhydride is our, what was the pet name of anhydride that we discussed? Yeah, the bullet. Yeah, the bullet, isn't it? The bullet was your anhydride. Yeah, so we have to prepare anhydride. Okay, what was anhydride? Anhydride was something like this: CH3, C double bond O, C double bond O, CH3. Yeah, so obviously, what should I take? Opposite reaction, Sasidharan. What should I take? 2 moles of acetic acid. Now instead of hydrolysis, we have to do the dehydration. We have to remove the water. Okay, so P2O5, Sasidharan, we use P2O5. Write it down. P2O5 is a dehydrating agent. P2O5, if you look at anywhere, it is a dehydrating agent. It is a dehydrating agent. So we use P2O5 and we heat it. We use P2O5 and we heat it. So what happens? Suppose I have Sasidharan carboxylic acid. I'll write it like this: OH CH3. Second molecule of carboxylic acid, OH. So what will happen? Dehydrating agent. We take away minus H2. Remove the water molecule. And what you have got? Write it down. Important, this is how anhydride. This is how anhydrides are formed. Come on, write it down. This is how anhydrides are formed. This is how anhydrides are formed. Write it down and tell me done. We'll try to finish the chapter today. Next lecture, Sasidharan, will keep for the chapter assessment. Done? Prashanti, is it done? So we have formed a very common reaction. It will be with you forever. Esterification. Okay, esterification. We know the functional group of ester now, Sasidharan. It is RCOOR. That is esterification. So what is esterification, Sasidharan? Look over here. Esterification means what? We have a carboxylic acid. What are we doing, Sasidharan? We are doing reactions of carboxylic acid. Yeah. So what is esterification? Always remember, if I have carboxylic acid, Prashanti, if I treat it with alcohol, always and always, what I'll get? I'll get an ester. I'll get an ester. Okay, so if I have a carboxylic acid, CH3COOH, okay, and I'm treating it with alcohol, Sasidharan, focus. I have a ester, I have an acid, and if I treat it with alcohol, okay, let us say I have CH3OH. I have CH3OH. So what will happen? Esterification. Yes, esterification. Yeah, H2O will go away and you'll get a ester. CH3, C double bond O, O, CH3. This is your ester. This is your ester. So hence we call it as esterification. I'll come to mechanism of this. First, write it down. Acid plus alcohol will always give you ester. What is the name of this ester? Prashanti, Sasidharan, tell me the name of ester. We have discussed the IUPAC of ester today. So tell me the name of ester.
Methoxymethanate.
Come again.
Methoxy
Huh?
methanate. Ethanate.
Always ignore this carbon. Do not ignore it. That is a 2 carbon, not a 1 carbon. Getting it, Sasidharan?
Yes, sir.
Do not do that silly mistake in the exam. Do not ignore the carbonyl carbon. It is methoxyethanoate. Methoxyethanoate. Come on, write it down, Sasidharan, and tell me done. Methoxyethanoate. I'll come to the mechanism of this. Yes, correct, Prashanti. Very good. Methoxyethanoate. 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 Done? Sasidharan? Prashanti done? Okay, now next. Sasidharan, let us understand the mechanism of this. Are you doing something else? Writing part? Sasidharan? No, no. Of your school project something? Project work?
So I was writing the name of the ester.
Okay. Now look at the mechanism. How does this reaction happen? Okay, now we have written H2O goes like this, but does it really happen like this? No, obviously not. Yeah. How does this reaction happen? See, oxygen. Okay, this can act as a nucleophile. We have seen alkoxy group can act as a nucleophile. If it acts as a nucleophile, where will it attack? Yeah, where will it attack? Obviously, it will attack at the your carbonyl group. Okay, and always remember one thing: esterification no is done in the presence of acid. It's done in the presence of acid. Okay, so what happens over here, Sasidharan? Oxygen has lone pairs. Okay, first thing what happens, it gets protonated. First thing what happens, it gets protonated. Now it requires electron. So those electrons, how did they get it? This methoxy group attacks over here. They get the electron. Correct. So what we will get in the first step, we'll have something like this: CH3, COH, OH, yeah, and the OCH3 with the H. Getting it? Now over here, Sasidharan, Prashanti, 2 OH on the same carbon is very unstable. Plus there is a positive charge on oxygen. So we want to get rid of 1 OH. So what happens, Sasidharan, is this, okay, H plus is transferred to one of the oxygen. This H plus is transferred to one of the oxygen. So what we will get? We will get a leaving group. OH2 positive. This becomes O. This becomes CH3. Yeah. And there is a OH over here. There is a OH over here. Now that H2 wants to go away, Sasidharan. So what will happen? There is a presence of lone pair over here. Lone pair close over here. H2 goes away. Correct? So what I'll get? CH3. C. I'll write it double bond O over here. OH positive. OCH3. And in the last step, yeah, your catalyst. What is a catalyst, Sasidharan? Which comes in the first step and goes out in the last step. So in the last step, what happens? The deprotonation. In the last step, deprotonation takes place and you get your ester. You get your, are you getting it?
Sir,
Yes, Sasidharan.
before like the formation of double bond, there is 2 H on like the carbon.
2 H on the carbon, which?
Like 2 H, like there is OH2 in the carbon, right?
So that's why.
But after the
See why that OH2 has come, because 2 OH on a single carbon is very unstable. Both are electronegative. Correct? So we want to get rid of one of the OH. We want to get rid of one of the OH. So what happens over here? Hydride transfer takes place. This H, okay, this H moves to the oxygen. Okay, not hydride, sorry, proton transfer takes place. Proton transfer takes place. That H plus moves to one of the oxygen. So we become a living group. That's why it has become OH2. H plus has gone, so positive. Okay, it has left behind its electron. That's why oxygen got stable. Oxygen got stable. And now it has become living group. So your lone pair closed and your H2O gone. H2O gone. Okay. And in the last step, the deprotonation, so catalyst you have got back. Okay, come on, write down the mechanism from this here start. So sorry. Not exactly from this, from top only it starts. Come on, write it down. Prashanti, I hope it is clear. Come on, write it down. After writing, tell me done. Prashanti, after writing, you have to tell me done. And do not just copy blindly. Understand what is happening. Yeah, understand what is happening, then copy. So Sudaran, done. Okay, sure. Now next, this reaction we have already done in the haloalkanes and haloarenes. that is reaction with PCl3, reaction with PCl3, PCl5 and SOCl2. Reaction with PCl3, PCl5 and SOCl2. Simple it is. All three are what? All three are your fluorinating agents. All three are your Sasidaran fluorinating agents. These are your fluorinating agents. Correct? So what they'll do, they'll give you Cl minus. Always and always remember, they will replace OH with the Cl. Okay, so if I replace Sasidaran in your acid, if I replace OH with the Cl, what I'll get? I'll get a acyl chloride. Simple. Yeah. Or we call it as acid chloride also. Suppose I have CH3, I have, I'll write it over here, CH3, C double bond O, OH. So simply, if I react with PCl3, what I'll have? CH3, C double bond O, Cl. If I react with PCl5, Sasidaran, again CH3, C double bond O, Cl. And if I react it with SOCl2, I'll get CH3, C double bond O, Cl. CH3, C double bond O, Cl. Now what is different is the byproduct. Okay, what different is the byproduct. Okay, over here 3Cl will give me H3PO3. Okay, over here I'll get POCl3 since there are 5Cl, POCl3 plus your HCl. Okay, and over here what I'll get? SO, since there is a SO, so I'll get a sulfur dioxide and HCl. Sulfur dioxide and HCl, but the product will be same. The product will be same. Come on, write it down. The product will be same. That is your RCOCl. And if you want the IUPAC name of this, Sasidaran, it is ethane. Since it is acyl chloride, carbonyl chloride, we write it as ethane OYL chloride, ethanoyl chloride, ethane oil chloride. Come on, write it down. Write down the reactions.